PROMYS 2022 Programming Mathematics for Young Scientists. We want to solve problem number 1 to 10. For having new videos, you can subscribe, turn on the bell to notice, and like the videos. My WhatsApp number is this, my mail is this. So for having the whole proof, you can contact. Okay, so let's see problem number 1. Calculate each of the following. So if you calculate, you would understand that the first one is this, second one, third one, and fourth one would be this. So you can guess that 1, n6, n0, n plus 1, 3 here equals 1, n6, 5, n0s, n plus 1, 3s. So you should prove these two things are equal. You have to use the closed form. You should change them to closed form and get rid of this dot dot dot. How? By only these two things. When you have, for example, n nines, 9 9 dot 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 9, you can say it equals 10 to the power of n minus 1. If you have 1 1 dot 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 1, it would be 10 to the power of n minus 1 over 9. So like this, you can change this, the left hand side and right hand side, to closed form like these things, and then prove the problem. So for the whole proof, you can send message through my WhatsApp or mail, but WhatsApp would be better. The next problem number 2. So let's consider problem number 2. It says to get the echo of a positive integer, we write it twice in a row without a space. For example, the echo of 2022 is this. Is there a positive integer whose echo is a perfect square? If so, how many such positive integers can you find? If not, explain why not. So we prove that there are infinitely many numbers that the problem wants. So I written two of them. These two numbers are correct, and there are infinitely many numbers that satisfy problem number 2. If you want to know, we should use a famous theorem. That theorem is useful also, I can say, in AIME for USA Olympiad, and also BMO for British Mathematical Olympiad. One of the one useful and famous theorem we should use. That theorem is also useful in many national mathematical olympiads. Okay, so for finding and seeing how we've reached these two solutions, you can send message as I said. Problem number 3. Problem number 3, it says any positive integer can be written in binary, and for example 37 is this because 37. Each step subtract, consider the maximum power of 2. So the first one, 37, the maximum power of 2, let's now recall 37 is 32. If you subtract it, 5 is left, then 4 plus 1, and 45 is this in binary. Let's say that a positive integer is scattered if in its binary expansion there are never two ones immediately next to each other. For example, 37 is scattered, but 45 is not, because 45 here we have two 1, here two ones for 45, but here we don't have adjacent ones. And it says this: how many scattered numbers are there less than 4? If you write, you would see 1 here, 2 here. So the answer of the first one is obvious. You have 2. 3, 4, 8. 1, 2, 3, 4. 8 is 4 less than 2 to the end. Okay. So I can say the answer is what? But how we can reach the answer again, the whole proof, you should send message to my WhatsApp number that is in the description. The first one, 2 to the power of 2. For 2 to the power of 2, the answer is 2. For 2 cubed, the answer is 4. For 2 to the power of 4, the answer is 7. Why? I can tell you, it's 2 plus 4 plus 1. 12 for 2 to the 5, the answer is 12. We can say 4 plus 7, the last two numbers plus 1. Sum of the last two numbers plus 1. So for 20, you say, okay, the previous one is 12. And the previous one is 7. 7 plus 12, 20. So less than 2 to the 6 would be this. So you found the sequence is what? And you can find by recursive sequence 2 to the n. So if you wanted the whole proof, you can send message. The next problem number 4. Problem number 4, it says show that there are no positive integers n for which this number is a perfect square. Are there any positive integer n for which this number is a perfect square? Is so, find all such n. Only one answer for the second one when n equals 3, and for the first one we prove. It has this problem has more than one solution, and one of them I explained for you. The first one you can say, okay, n plus 1 to the power of 4 minus this number, the first one, equals n plus 1 to the power of 4. We want to prove it by contradiction, minus a squared if it is a squared. And so if you subtract, it would be n to the fourth minus this, n to the fourth would be cancelled. 4n cubed minus 2n cubed would be 2n cubed. And 6n squared minus 2n squared would be 4n squared. 4n minus 2n is 2n, and 1 minus 1 is 0. So it is equal this. Now you can factor from 2n, it would be n squared plus 2n plus 1. So it would be 2n times n plus 1 squared. Now if you pay attention to this number, we would find what? We would find a squared, take a squared to the right hand side, equals n plus 1 to the power of 4 minus 2n, n plus 1 squared. We factor from n plus 1 squared, and it would be n plus 1 squared minus 2n. And it would be n plus 1 squared times n squared plus 1. So we know it is perfect square. Here is perfect square. So n squared plus 1 must be perfect square, and easily you can prove it is impossible, because if n squared plus 1 is a perfect square, then you can say 1 equals x squared minus n squared, which equals x minus n and times x plus 1 without loss of generality. We know n is positive, n is greater than equal 1. Without loss of generality, we can say x is also positive, greater than equal 1. So when the production of them is 1, so x plus 1 must be plus minus 1, and none of them can happen, so contradiction. The second equation can only be perfect square when you replace n with 3. For n3 you can replace, but why the only answer is n equal 3 for this part? If you want the whole proof, send message through my WhatsApp number in the description. Now let's consider problem number 5. Problem number 5 says the rectangular floor of a bathroom is covered with square tiles, all of the same size. A spider starts at one corner of the bathroom and walks to the corner diagonally opposite. For example, the figure below shows a 6 by 8 bathroom in which the spider touches 12 tiles on its path. A spider doesn't touch a tile if it just walks over the grout at the corner of a tile. For an M by N bathroom, how many tiles does the spider touch on its walk? The answer is M. If we have table is M by N, so the answer is M plus N minus GCD of M and N. Here, if you check, M is 6 plus 8 minus GCD of 6 and 8 is 2. 14 minus 2, 12, and 12 is the answer. So, for finding why the answer is exactly 12, you can send message through my WhatsApp number in the description. So, the last answer is M plus N minus GCD of M and N. The next problem number 6. Problem number 6 says a monkey has filled in a 3 by 3 grid with the numbers 1 to 9. A cat writes down the three numbers obtained by multiplying the numbers in each horizontal row. A dog writes down the three numbers obtained by multiplying the numbers in each vertical column. And the next of that vertical column, let's find. Okay, so writes down, okay, multiplying the vertical column. Can the monkey fill in the grid in such a way that the cat and dog obtain the same list of three numbers? Okay, I said example, this part I solved it completely here for you. 378245961. So consider the rows. 3 times 7 times 8 is 168. 2 times 4 times 5 is 40. 9 times 6 times 1 is 54. And also if you multiply the column, it would be a permutation of exactly these three numbers: 54, 168, and 40. So for finding out how you can reach this answer, you can send message through my WhatsApp number in the description now. Let's consider 5 by 5 is so much harder than 3 by 3, and the answer is yes, it is possible. The answer, you can check this 3, 22, this. If you check this table, consider the multiplication of rows and columns, you can find, so for 5 by 5 the answer is yes, but finding out this answer is not easy at all. I can explain for you if you want to send message through WhatsApp, so how we can reach this table. And for 11 times by 11 the answer is impossible, no, and it has a proof. If you want to send message through my WhatsApp number, and also you can generalize this idea for n by n, because the problem says the last case consider n by n. See that, can you guarantee that it is impossible or possible? Okay, so I said 3 by 3 completely here, 5 by 5 completely here. For 11 by 11, I only said the answer is no, but the rest of that, the whole proof, you can send message through my WhatsApp number, the next one, or email. Problem number 7. This problem says, let's read the problem completely. It says g of 12 is this, a of 12 is this, for which n is g of n an integer, a of n is an integer. So here you can prove easily that if g of n is an integer, so n is a perfect square, and you can write the formula. If n is p1 p2 to pk, an is p1 plus 1 over 2 pk times pk plus 1 over 2, and p1 to pk are prime numbers. You can say for all these numbers an is integer. I said y, so for proof of this why n must be perfect square, you can send message through my WhatsApp number. For an 6, I write all numbers, it has only three answers: 11, 14, 15. For an equals 124, we have exactly 5 answers, and this part is so much hard: 1 to 4. If you want to find out how I've reached exactly these 5 answers, you can send message through my WhatsApp number in the description, or email. An is, so it says conjectures. You can generalize anything you find. It's open-ended question. This, the last part, you can find out. The hardest part of this problem is this part: an equals 1 to 4. Many students could find only one answer or two answers. I didn't see any student that could find all these 5 answers, so we can prove that the answers are only these 5 answers. If you wanted the whole solution, send a message through my WhatsApp number in the description. Problem number 8. It says we have, let's read the problem completely. The set S contains some real numbers according to the following 3 rules. 1 over 1 is in S, A over B is in S, where A over B is written in lowest terms. That is, A and B have highest common factor 1, then B over 2 is in S. If A over B and C over D are in S, where they are written in lowest term, then a plus c b plus over b plus c is in S. These rules are exhaustive. If these rules don't imply that the number is in S, then that number is not in S. Can you describe which numbers are in S? Okay, I prove that x over y is in S if and only if the first condition, x and y are positive integers. Second condition, GCD of x and y must be coprime numbers, and x, the numerator, must be greater than equal 1, less than or equal denominator, and also denominator over 2 must be less than or equal x. So, from you should prove if and only if from left to right it's easy, but the hardest part is proving from right to left. So if you wanted the whole proof, that's why we can say from right to left that for any fractions like this, they are in S. As I said, you can send message through my WhatsApp number in the description. Problem number 9. Okay, so let's consider problem number 9. Let's read it completely. Let P0 be an equilateral triangle of area 10. Each side of P0 is trisected into the three segments of equal length, and the corners of P0 are snipped off, creating a new polygon. In fact, a hexagon P1 was the area of P1. The area of P1 is this 20 over 3, the first one. Then we do this and we reach P2, the area of P2, 160 over 27. Now repeat this. P infinity is 40 over 7. And if you wanted the shape or how we've reached these three numbers, P1 and P2 are obvious, but P infinity is harder. So if you want to find out how we can prove and reach these three numbers and the shape, you can send message through my WhatsApp number in the description. The next problem, problem number 10, is on a strange railway line, there is just one infinitely long track, so overtaking is impossible. Anytime a train catches up to the one in front of it, they link up to form a single train moving at the speed of the slower train. At first, there are three equally spaced trains, and at first there are, as said, three equally spaced trains, each moving at a different speed. You watch, and eventually, after all the linking that will happen has happened, you count the trains. You wonder what would have happened if the trains had started in a different order, but each of the original three trains had kept its same starting speed. On average, averaging over all possible orderings, how many trains will there be after a long time has elapsed? What if at the starting time? Okay, so for n3, for general n, the answer is 1 plus 1 over 2 to 1 over n. So for n3, the answer would be 1 plus 1 over 2 plus 1 over 3, which would be 11 over 6. For n4, the answer is 1 plus 1 over 2, 1 over 3 plus 1 over 4, which is 25 over 12. Let's check the sum. It's 11 over 6 plus 1 over 4, so it would be 12, 30. Let me check. Okay, 22 plus 3, yes, 25 over 12. And the last one, n, so we've solved n3. And what if at the starting point 4 trains is found 4? For 5 also the answer is this. For n the answer is this. So I said the last answers for all the cases, but how you can reach these answers, and if you wanted the whole proof, as I said, send message through my WhatsApp number or email in the description.